Hi, 7th grade. Welcome to lesson 7-6, Find Probabilities of Compound Events. By the end of the lesson, I want you to be able to say, I can find the probability of a compound event. Let's solve and discuss it. Talia is playing a game in which she must choose option 1 or option 2, and then spin the game wheel, flip the coin, and roll the number cube labeled 1 through 6. For her to win a prize, all the conditions listed under the chosen option must occur. Which option should Talia choose? Explain. So option 1 is that the game wheel lands on S, the coin lands on tails, an even number is rolled. Option 2 is that the game wheel lands on Z, the coin lands on either side, and the number 3 is rolled. So let's go through and decide which one would be the better option for her to do. Which one she'd have the best probability for. The game wheel lands on S. There is only one S out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 options. So landing on S is a 1 out of 15. Coin landing on tails is 1/2. And an even number being rolled is also 1/2 because it's 3 out of 6. Option 2, the game wheel lands on Z. There's only one Z out of 15. So these two things have an even probability. The coin lands on either side. Well, that's certain to happen. That's 100% going to happen. So for option 2, that's more likely to happen. So right now, option 2 is looking pretty good. Then option 3, the number 3 is rolled. That's only a 1 out of 6 chance. So we need to decide which is better. Is it the probability that landing on either side and a 1 out of 6, coin landing on tails, or an even number is rolled? Well, this is both equally likely on option 1, and this is certain and unlikely. I would probably go with option 1 because 1/2 is better than 1/6, even though 1/2 is less than 100%. Focus on math practices. Suppose an option 3 was added to the game with the conditions that the game wheel lands on Q, coin lands on either side, and the odd number is rolled. Should Talia change her choice to option 3? No, because it's the same probability. Oh, actually, no, it's not. If it lands on Q, that's the 1 out of 15, so that's the same as the other ones. Coin lands on either side, that's 100%, and an odd number is rolled, that's 1/2. So 1/2 is greater than 1/6, so it's better than option 2. So yes, because she has a higher probability of winning. Because then we have 1 out of 15 is unlikely, but that's unlikely for all the options. Then 100%, which is certain, and then 1/2, which is equally likely. And equally likely is better than unlikely. Example 1, find the probability of compound events using a table. Sadie has 1 ticket left at the school fair and she hasn't yet won a prize. She decides between 2 games, which game should she play? So flip to win is to flip 2 heads to win a prize, and flip and spin is flip a head and spin blue to win a prize. Does having more possible outcomes make it more likely or less likely that Sadie will win? So step 1, use a table to determine the probability of winning a prize with flip to win. There are 4 possible outcomes, and 1 is favorable when you get both heads. So she has a 25% chance of winning if she plays flip to win. Step 2, if she plays flip and spin, winning a prize is flipping head and spinning blue. So that only happens 1 out of 8 times, so 12.5%. So the more options there are, the lower your percent because the denominator is going to be out of a bigger number. Step 3, compare the probabilities of winning each game. Probability of winning a prize at Flip to Win is 25%. Probability of winning at prize at Flip and Spin is 12.5%. Sadie is more likely to win a prize playing Flip to Win, so she should use her last ticket to play Flip to Win. Let's try it. The designer at Flip and Spin creates a new game using a 5-section spinner as shown. How does the new spinner change the probability of winning a prize? Using the 5-section spinner, the probability of winning a prize is blank. So it's the same thing. You gotta flip a head, so that's a 1/2 chance. And you gotta get blue, which is 1/5 chance. So we can make a table or a list. Let's do a list because we haven't seen an example of that yet. We could get heads in orange, heads in green, heads in yellow, heads in blue, heads in red. Or we could get tails in orange, tails and green, tails in yellow, tails in blue, and tails and red. Remember your curly brackets. The only way you win is if you get heads in blue. That's 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Remember, the number of outcomes we multiply. So like there's 2 and 5. You multiply that. That's going to give us 10. So it is not likely that a player will win a prize when using the 5-section spinner than winning. It's less likely. Less likely that a player will win a prize using the 5-section spinner than when using the 4-section spinner. What generalization can you make about the number of sections on the spinner and the probability of winning a prize while playing Flip and Spin? So the more sections, the least likely you are to win. Because the more sections you make, the more outcomes there are going to be, the more losing outcomes there are going to be. Example 2, find the probability using a tree diagram. What is the probability that a coin flipped 3 times will land heads up exactly twice? So we're looking to find out which ones will it land heads up twice. This is one of them. This is one of them. And this is one. That's 3 out of 8, or 37.5%. It is more likely that a coin flip 3 times will land heads up exactly once, or will land heads up exactly twice. Explain using probability. So we just found out how often it does when it lands heads up exactly twice. Let's find out what it is when it lands heads up exactly once. That's this one, only 1 heads. And this one, only 1 heads. And this one. So it's still 3 out of 8. So it is not more likely. It's equally likely. They're both 3 out of 8, or 37.5%. The probability using an organized list. The names of all middle school students with perfect attendance are entered into a drawing for one of 2 tickets to a baseball game. This year, Angie, Phil, Mark, Carly, and Josie attended the school every day. What is the probability that Mark's name will be drawn to win one of the 2 tickets? So make an organized list of the possible outcomes for the winners of the 2 tickets. If Angie wins the first ticket, it could be Angie and Phil, Angie and Mark, Angie and Carly, Angie and Josie. Carly wins the first ticket, Phil, Josie, and Mark. Look at all those options. In green are all the possibilities that Mark will be drawn. There are 20 possible outcomes, and out of the 20 outcomes, 8 of them Mark is in. So that's 8 out of 20, or 40%. Does Mark have a greater chance than Carly of winning the tickets? Explain using probability. So let's look to see how many have Carly in them. 1, 2, 3, 4, 5, 6, 7, 8. It's still 8 out of 20. So no, they have an equal chance. Okay, 7th grade, let's say it. I can find the probability of a compound event. Have a great day.